Hello, young math Padawans. It's Mrs. Angel with your lesson for today on how to find the vertex in a quadratic that's in intercept or factored form. So intercept factored form looks like this. The reason why it's called intercept form is actually this is the form that allows you to read the x-intercepts or the zeros of any quadratic, but we'll get to that later. We also call this factored form because, as you can see, there is no square here. We don't see an x squared anywhere in this form. However, this is written as a product with two binomials in it, which is how you know that you are looking at something in factored or intercept form. The three steps to finding the vertex in this form, since the vertex is the most important point on the parabola, are as follows. Step one is you need to identify what's called P and Q. Now that might sound familiar to those of you who've done factoring with us in the past of the P's and Q's game. You'll also see P and Q in the formula here. Step two is to identify the axis of symmetry. And of course, step three is then to calculate the vertex using the value of x from our axis of symmetry in step two. So let's take a look at our first example. Our first example is y equals 3 times the group of x minus 4 times the group of x minus 6. So step one is to identify our p and our q. If you notice carefully, the formula has subtraction in it. So we're subtracting p and we're subtracting q. So a lot of you might think, well, isn't p -4 and q -6? Unfortunately, that's not how you can think about that. If the formula had addition, then you would be right. But since the formula is subtraction, you need to look at what's actually being subtracted in each group. There's another way to think about it, and it's similar to how we handle vertex form. The value of P and Q would cause both of those to equal 0. Okay, so let's go in and do some mental math. So in our first factor here, x minus 4, what value of x would cause that to be 0? That would be 4. So we can say here that our p is 4. And that also matches what we see in the formula. If the formula is x minus p, and here we have x minus 4, that matches up. Over here in our second group, what value of x would cause that to equal 0? That would be positive 6. So q here would be positive 6. And that also matches what we were given in our formula. Since the formula is x minus q, if we have x minus 6, that means the value of q here is 6. Now that we have this p and q value, which are actually, as you're going to find out later on, the zeros of the function, we are now going to move on to step 2 and calculate our axis of symmetry. So as we remember, the axis of symmetry is the vertical line that goes straight down the middle of the parabola. Since 4 and 6 are both the zeros of this parabola, the axis of symmetry is going to be the point directly between them. That means to find the axis of symmetry, we're going to find the average of P and Q. Here's how this works. The formula that we're going to use is x equals our value of P plus our value of Q, all divided by 2, since that's how you find an average. So let's go ahead and do just that. X equals, P here was 4, plus our value of Q, 6, all divided by 2.
4 plus 6 is 10, and 10 divided by 2 would give us an axis of symmetry of 5.
One way that you can check your work here is that 5 should be directly between 4 and 6 on a number line. 5 is 1 unit away from both 4 and 6, which means this is the line directly between these two values. Now that we have our axis of symmetry, finding the vertex is pretty simple. Since the vertex is just any old point with an x and a y, if we know the value of x, or the input, we can find the value of y, or the output. Since the vertex lives on the axis of symmetry, we already know that the input for this vertex is 5. Now we can use this information to plug 5 into our function and find the y value of our vertex. So let's go ahead and do just that.
Y equals 3 times 5 minus 4 times 5 minus 6. Y equals 3 times 1 times negative 1. Y equals 3 times negative 1.
And 3 times negative 1 is negative 3. So the y value, or the output of our vertex here, is at negative 3, making our vertex of this function 5, negative 3. Let's move on to example 2. Example 2 is the function y equals negative group of x plus 7 times group of x minus 3. Don't worry so much about that negative out in front. That's just a hidden negative 1. So step 1, let's find the values of p and q. Let's start with the value of p in our first factor. So since this is x plus 7, you might think, well, p would be 7. But hold on a sec. Since this is adding 7, we know that adding is equivalent to subtracting a negative. So here, the value of p would actually be negative 7. Another way to think about it is, what value of x would cause that to be 0? That would be negative 7. So our p here would be negative 7. The second factor is a little bit more straightforward. We have x minus 3, so our value of q here would just be positive 3. Another way to think about it is, what value of x would cause that whole factor to be 0? Well, that would be 3. 3 minus 3 is 0. And that's our value of q. Now that we have our p and our q, we can substitute that into our formula for axis of symmetry. Again, that formula is x equals p plus q divided by 2. We're taking the average of these two zeros to find the point that is directly between them, or the axis of symmetry that's cutting the parabola in half. So here we go.
That would be x equals negative 7 plus 3 divided by 2. Negative 7 plus 3 is negative 4. Negative 4 divided by 2 is negative 2.
So we have our axis of symmetry. We know that it is going to be at x is negative 2. Now to double check that, you could think to yourself, is negative 2 directly between negative 7 and 3? So think about it as, if I had a number line, negative 7 and 3 are the same distance from negative 2, meaning that these are equidistant from the axis of symmetry. So in other words, our axis of symmetry actually makes sense here. Finally, now that we have our axis of symmetry, we can calculate our vertex. We know that the input of our vertex, or the x value, is negative 2. We can use that information to plug it into the function and find our y value. So let's go ahead and do just that.
Y equals negative 1 times negative 2 plus 7 times negative 2 minus 3. Y equals negative 1 times 5 times negative 5. Y equals negative 5 times negative 5.
And y equals 25. So our vertex is at the point negative 2, 25. And that, young math Padawans, is how to find the vertex in intercept/factored form. That's it for today's lesson. I will see you next time.